All right, so here we have our scope, and right now it's just showing our sine wave. And again, this is a frequency of 1600. Now we can use the measure button. So if we use this measure button up here, and we can say show us channel 1. So right here it says channel 1. So we're going to press that, and I want to see the frequency, and I want to see the peak to peak value. Okay, and so it'll display those on the screen. It may be a little hard to read them, but we can see the frequency is 16.0, kind of toggles between 16.0 and 15.99 kilohertz. And so to get rid of the menu displays, we hit this bottom button down here. And so here's our sine wave. Now the peak to peak value for this looks like it's at 10.3 volts. Okay, so what I'm going to do is I'm going to download this because we want 4 volts peak to peak. And so I'm going to adjust this a little bit. And now all of a sudden you see that the trace is just kind of going wild. That's because of my triggering. So the first thing I'm going to do is change the scaling here. And then I'm going to adjust the trigger level. Now the trigger level is over here. Right here is the trigger level, and as I adjust that, you see that yellow line come up and down. So I'm going to get that closer to 0. You don't want it at 0 because noise will give you false triggering. Alright, so now we're looking for 4 volts peak to peak. So I'm a little bit low right now. And so we want to adjust this so we get to, I'm a 3.98 volts peak to peak for channel 1 now. So again, this is my supply voltage. So this is my reference. Now I'm going to turn channel 2 on. So I'm going to press the channel 2 button. And we get channel 2. Now it looks pretty small. First thing we always need to do is make sure that the probe matches. So I'm using a ×1 probe, but you need to make sure that the scope understands that. And so I'm going to adjust this to make it a little bit bigger. Now if I press measure, I can come over to measure and I can go to channel 2, and I want to see the peak to peak of channel 2. Now there's no reason to see the frequency of channel 2 because channel 2 is being driven by the yellow, the supply voltage, and so the frequency is going to match. So you can see here it's at 2.9 volts. Okay, so the 2.9 volts. So we calculated, and write down the value I calculated. So we calculated 2.8. So it's a little bit off from what we calculated, but it's pretty close. Okay, now I didn't actually measure my resistor or my inductor, so they may not be exactly 10 millihenries and 1000 ohms. And so that would certainly account for some of the difference. Okay, but it's fairly close there. Now, and there's also some noise. So when you're using these readings here, sometimes these values are going to be a little bit off because if you look at them, you can kind of see some noise in those traces. And so those values are sometimes off. So I'll do another video to show you how you can use the cursor to read those values. All right, so now we can see the peak to peak value, and we can measure this phase shift between these two. So if we go to channel 2, so I'm under measure, channel 2, and I'm going to scroll this, use this big wheel, and I'm going to scroll way down. It's off the screen here, so we've got to keep scrolling. And if you scroll far enough, you'll see the phase. And so if I press this, I'll see the phase, and I want to see the phase of channel 2 minus channel 1. Okay, and so when I do that, you can see it right here. It's 42 degrees. So remember, it was supposed to be like 44 to 45 degrees. It was 42 degrees. Again, there I did not measure the resistance and the inductance, and so a little bit of discrepancy there. We'll adjust that. Now notice this is channel 2 minus channel 1, so it's minus 42. So I really should have, let me go back to channel 2. I'm going to shut that one off. I should have done it on channel 1. Okay, because we can tell, scroll way down here and turn this back off. Phase. Okay, and I'm just going to turn that off, and I'm going to go to channel 1 and turn it on. All right, and so the key here is that our reference is channel 1, so we really want channel 1 first. So I'm going to turn that on. So I'm going to have channel 1 minus channel 2, and that'll give me the positive phase angle. And while I'm at the phase, I'm going to go ahead and do channel 1 minus math. Now I haven't shown you math yet, so I'm not sure if it'll display correctly. Yeah, it's giving me a question mark for the math because I haven't turned math on yet. Okay, but you can see here channel 1 minus channel 2, so that's our E minus the blue, and that gives us a positive 42, 43 degrees there. And again, we can see that, right? The blue is in front of the yellow. It's crossing 0. The blue is crossing 0 before the yellow. And that's because the voltage is leading the current. And so the voltage is going to be ahead in this circuit. Now, if I press this red button that's labeled math, it's got a big M on the button itself, that is the yellow minus the blue. Okay, and so its sources, it shows you here, if you can read this, channel 1 minus channel 2. So that gives us VR. That's Kirchhoff's voltage law. We have channel 1, which is yellow, minus channel 2, the blue, and that gives us the red. And we can change the scaling of that if we press this button here, and we can change it and make it a little bit bigger there. And then if we go to the measure button again and we select math, so we select this fourth button down and select math, I can say show me the peak to peak. And now I had already selected the phase channel 1 minus math, and that's still not reading for some reason. Let me turn it off and back on again and see if it likes to read better. Okay, so I go to phase, and I'm going to shut that one off and turn it back on again. Alright, so now we're actually getting a reading there. Channel 1 minus math, I guess it's still not reading here for that one. Okay, so but you can see the peak voltage, it looks to be about 2.8. That red's really dark. It may not be showing up very good on the scope here, or on the camera here, but it's about 2.8 volts also. Now notice here that the red is behind the yellow, all right, because the current is lagging, and it's lagging the blue by 90 degrees. So if we look at the difference between the red and the blue, it's 90 degrees. So if I go to channel 2, and I'm going to go ahead and come down here and measure the phase, and I want to look at the phase difference between channel 2 and math, and hopefully it'll actually display it for us. Alright, well now we're getting channel 1 math, which is minus 45, and channel and phase one is 43. Okay, so it's actually 45.6 and about 43. And I think we're only allowed 6 of these on here. So to show something, I'll have to show something, turn something else off. So let me turn off the frequency now that we've verified it. I won't be changing it. So, and then I'm going to go to channel 2, scroll all the way down off of the screen to phase, way down here. So down to phase, and I'm going to press phase, and I want channel 2 minus math. Okay, so now we can see here, oops, I think I hit the wrong button. Sometimes when you're scrolling, at least I do, I tend to scroll and as I'm pressing the button, which messes it up. So I think I've got this delay. I don't want that delay there. Okay. Delay RR. Where is that? There, right there. Yeah, see, it was right under phase. I need to disable that. Okay, so those are gone now. So then I'm going to go back to phase, and I want channel 2 math. There we go. And you can see it's minus 88, almost 89 degrees, right? It's supposed to be 90-degree phase shift. So that's pretty close to 90 degrees. So that's the blue, between the blue minus the red is 90 degrees. So the red is 90 degrees behind the blue waveform, and that's the current, because the current is in phase with the resistor, and it's 90 degrees out of phase with the inductor. All right, but this is how we can use this measure feature on the scope to view the values. Now, when you're doing this, notice you got to have a good waveform. So if my waveform is off the screen here like this, if I've adjusted my time function and I don't really have a full sine wave, then it can't read phases. Okay, so the phases, all the phases are question marks now, because I don't have I need at least one complete cycle, okay, to get a good reading. Also, if the voltage is too big, it clips. So if you look at my peak-to-peak voltage here, it has a question mark because it's clipped. And also the phase angles, it can't read phase angles because they're clipped. Okay, and also the math, because it's clipped, the red of the math is really weird looking because I'm clipping my yellow waveform. Okay, so you need to make sure you use as much of the screen as possible without going beyond the screen. And so you really want to see about 1 to 1.5, no more than 2 traces most of the time to get good readings. All right, that's it for this video.